And so he is the COO and Vice President of Sustainability. Thank you. And he and his team are responsible for supply chain operation, production, sustainability, and distribution of the Rhizosorb, supporting growers across the United States. So with that, thank you, Steve.
Thank you. Yeah, so many hats. And James stole my thunder. I was thinking 2 o'clock is probably the worst time to speak. So if Carl starts snoring, we'll just throw something at him, get him up. So today I'm going to talk about lowering carbon intensity while improving phosphorus efficiency. Yeah, sure. Phospholutions. I'm going to go through quickly the both us and our technology, so you could understand that. Can I actually get a hand mic, because I got to move around. Sorry. That work? Okay, good. So enhancing global phosphorus use is our mission, our values. Mindful, original, and bold. And really at Phospholutions, our belief is that we believe sustainable and responsible production of phosphorus is fundamental for reducing phosphorus loss and increasing phosphorus efficiency, improving the farmer profitability, and lowering cost of production. And then the biggest thing for me is reducing the environmental impact of phosphorus. So when I was going through these slides last night, I was thinking I probably should have thought about the audience a little better, but I wasn't sure of the people here and what they knew. But I'm going to go through this slide pretty quickly. Most of you probably know most of this already. Estimates are about 80% of the phosphorus that's placed in that crop that year is not utilized by that actual crop. And so essentially you're placing that phosphorus down, the farmer's paying for that phosphorus, and it's not actually being used by the crop in that crop year. So essentially what's happening is they're losing that material to the water resource. The USGS Sparrow model estimates approximately 6% loss across the US of chemical fertilizer to the water resource. So the farmer's paying for this material, putting it in a bank, and then losing 6% every year. So clearly not an efficient process, and obviously also has environmental impacts, which is the second point, the global impact. The water resource impact from that is substantial. And then from the carbon side of things, you have 1.7 metric tons of C2OE per P2O5 ton. So essentially you've got a large carbon emission source. So, and then finally, there's debate about this of, it's a finite resource. How long phosphorus do we have left? 100 years, 500 years? But at the end of the day, it's a finite resource. Most of it in one region of the world. And so it is something we should use more sustainably. So next generation of phosphorus fertilizer, Rhizosorb. I think the biggest thing I want to get across right now is on the farmer side. What we're finding with our 50% reduction of P2O5 use is a ROI of up to $20 per acre to the farmer. The environmental aspect, 45% reduction in carbon emission, and also a 78% reduction of runoff potential. It's also better profitability for the retailer and also the producer, and it's scalable and easy to use. So Rhizosorb development history. So in 1991, Dr. Jonathan Lynch at Penn State University started studying this technology. Dr. Lynch studied it for probably a good 25 years. There's many peer-reviewed studies on this active ingredient. Hunter Swisher, our CEO and founder, had Dr. Lynch as an undergrad and was asking about the technology, asked where it was going, what was going on with it, and there really wasn't much happening. So he licensed 2 patents from Penn State and started Phospholutions in 2016. 2018, studied in small plot. 2021, did performance and farm trials. And then in 2023, spring of 2023, we launched our product into the ag market. So how does it work? It's embedded directly within the phosphorus granule. So essentially during the phosphorus production process, we inject our active ingredient. Mimics natural soil chemistry, but I would say that it takes natural soil chemistry and puts it on steroids. So essentially you have a product that will adsorb and desorb phosphorus readily. And so as the plant will take 1 unit of phosphorus out of the soil water complex, our product will desorb and put a unit back into that soil water complex. So you really get a positive effect from the standpoint of you place MAP, it dissolves, you get a large plug of phosphorus, and then it gets locked up by the soil, where our product will keep that in a label form so it actually can adsorb, desorb as the plant needs it and draws from it. Increasing nutrient uptake. I mean, I think the biggest thing on this slide that I wanted to point out is the graph in the upper left. So we've tested this across multiple soil phosphorus content. So essentially low phosphorus soils, optimum soils, high phosphorus soils. In each case, you put 100% MAP down, you put 50% P2O5 and our product down, and you're getting the same or better yields with our product across all those soil phosphorus contents. So this is a busy slide, not as busy as Carl's, but what we wanted to point out here is that we've got plenty of research that's been done on this product, over 500 trials completed, and on the large farm trial side of things where we do 20 acres of 100% MAP and then 50% P2O5 and our product on the other 20 acres, we've got about 150 trials that we've done on a large farm scale. This is a multi-year Penn State study, 19 to 22. On the left, crop yields, again, doing 100% MAP, and then in comparison doing 50% P2O5 and our product and getting the same yields or better yields. And also on the right, you've got the leaf tissue phosphorus content. Again, very similar results using 50% less P2O5 compared to the grower standard practice. On-farm trials. Actually, you know what? I forgot to mention something here on the Penn State side. So just recently, Dr. White at Penn State had recommended us as an enhanced efficiency fertilizer to Pennsylvania US NRCS. The Pennsylvania US NRCS has approved us as an enhanced efficiency fertilizer in PA. And we just met with APCO on Monday and running through both beneficial use determination and enhanced efficiency fertilizer determination by APCO. On the farm trial side of things, 16 states, large farm, again, 20 acre, 100% P2O5, 20 acre, 50% P2O5. You could see the yield results on the right there, +5 bushels per acre, +3 bushels per acre, +2 bushel per acre. We don't make a yield claim at this point. We're just telling the farmer, look, you're going to save money by using our product, and you're going to get the same yield, and you have less environmental impact at the end of the day. So this is the exciting part for me and what I'm passionate about. So the reduced runoff potential. We had a third party in New Zealand do simulated rain events, 100% MAP in our product, and they showed a 78% reduction of phosphorus coming off the soil with our product used versus MAP. The leaching side of things, Dr. Lynch had studied this significantly through his time at Penn State, had a range of anywhere from 70 to 98% reduction in phosphorus leaching, 84% being the average. On the next 4 bullet points, so we completed a life cycle assessment in accordance with ISO standards last year. The boundaries of this LCA, mine to crop yield, corn being the crop, and manufacturing overseas, shipping the product to the US, utilizing it in the US to grow that corn. So as you can see, decrease in eutrophication 40%, decrease of carbon emissions by 45%, and then decrease in freshwater and marine aquatoxicity in the 44 to 46% range. So what's that mean from a carbon reduction potential? So our consultant calculated in the US about a 3.4 million ton reduction just if 100% of the farmers farming corn that year utilize our product. I took that and just to get a rough estimate across the globe, it's about 11 million tons per year just in corn if you use our product versus other phosphorus products. On the water quality side of things, so I dealt with the Chesapeake Bay issue quite a bit in my time at Purdue Farms. These are direct numbers right off of the Chesapeake Bay program's website. The Chesapeake Bay program, if you don't know, is within EPA. They have the model that estimates nitrogen, phosphorus, and sediment coming off of wastewater, agriculture, anything you could think of that would actually put nitrogen, phosphorus, and sediment into the bay. Their estimated 2022 chemical fertilizer loss was 2.8 million pounds. Again, if you transition those farmers from their current phosphorus fertilizer to our fertilizer, that would be 621,000 pounds, quite a reduction. The big thing is in 2025, the TMDL that they're chasing, they have goals for 2025 to meet nitrogen, phosphorus, and sediment numbers. 13.3 million is what phosphorus number they have to meet. If farmers in the Chesapeake Bay region, 100% of them switched over to Rhizosorb, we would meet that today. So clearly would have a substantial impact on runoff potential. So after sitting through all the meeting, it was good to hear some of the great academic work being done. So I have a question out to the group, and you can either get to me after the talk or email me. One of the things we're trying to quantify, and I already asked Matt about this, and he did not have any ideas through his contacts. Our eutrophication reduction is substantial. And with eutrophication, we all know there's a large methane production. Methane has a very high global warming potential. So what we're trying to get a hold of is any peer-reviewed studies that anybody knows of where it shows the percent reduction of eutrophication drives a certain reduction of methane. Because if that is present or available, then we can go back in and under ISO go after additional carbon emission reductions. We think it'd be pretty substantial. So that's all I have for today. Sure. Yep, thank you.
Buying the product, or are you equating it to if a manufacturer doesn't produce or produces 50% less phosphate that year, that's the greenhouse gas component?
It's both. So essentially, our product is much more efficient in the production side of things. It uses a lot less phos acid, uses a lot less ammonia, and there's other proprietary items that are much more efficient than typical MAP production. So part of it is just you only need 50 pounds of P2O5 versus 100, and part of it is the actual production process is much more efficient. And then our proprietary material doesn't have a massive carbon footprint associated with it, so that additive material doesn't add a lot to the equation.
Over here. So since the product is essentially a scaffold and it's not consumed during the season, is it one application only?
It is one application only. It's the same as MAP or DAP. Essentially, that the material will absorb, desorb throughout the growing season.
Yeah. Well, how many seasons does it last?
So this question came up last night. Our push right now is that you would have to put it on every season, and so that the thinking there is because you're reducing that amount by 50%, we don't want to have any issues with the soil P and causing problems there.
I was just going to point out about the methane leachification connection. So the work of John Downing and his group has quantified the relationship between pea loading and methane emissions.
Okay.
So those data are, they're right here.
Yeah, yeah.
So hopefully you can make those calculations, on the taxi to the airport or something like that. So
Well, I'd have to pay the consultant to do that, but yeah,
Right.
yeah.
Okay.
Do you have any plan for scaling the process to the industrial scale? And what difficulties do you expect?
Scaling the process, and I'm sorry to hear you, the door closed.
Yes, scaling the process to the commercial scale.
Oh, yeah.
And what difficulties do you expect?
Yeah, so we just did a large production run. We sold product last spring, of course, last fall, and we're ramping up our sales for this spring. I'd say, so it's an 8390 product. We have a lot of interest. I think the hardest part, and one of the things we debated, was just the percent reduction. Sometimes you walk into a farmer and say, reduce your P2O5 by 50%, and they're like, well, I've been doing this for 40 years. That's a lot of reduction. So it's really just convincing the farmer that, look, this works. We've got a ton of data to back it up. We've done a ton of trials, and most of the demo farmers we've worked with transition into immediate buying of products. So really, I mean, it goes back to what Carl had mentioned before, and I think Ron was talking about yesterday. Being a small startup, it's always difficult getting past that initial startup and phase. But we're doing well. We've got a lot of interest from retailers, and so it's just keep pushing along and sell it.
I was just wondering, I looked at your commercialization trial history graph or table, and I was wondering if you guys plan on doing any large acre trials for turf grass.
Actually, ironically, most of, well, I shouldn't say most, a lot of the work that Dr. Lynch did was in turf, and we had a turf product that we were pushing and then decided it was better to go after ag. So we do have some work in turf. I mean, I guess it depends on what exactly they're talking about. We did a lot of work with golf, and it's an excellent product in greens.
Yeah, the only reason I asked that is my understanding is turf grass is the largest user of water, the largest crop user of water in the country or in the world, maybe. So it might be, and I'm sure Arizona would benefit from something like that.
Yeah. So we have done work there. Right now, our focus is ag. So
how many acres in the U.S. is your product being used on today?
Oh, good question. I don't know that off the top of my head. I'd have to get with commercial. Yeah, sorry, I don't.
I just have one question regarding the, to make that phosphorus so released. Maybe you have used some additives. I don't know. You didn't talk about the technology you have used. Maybe aluminum, I don't know, to make that phosphorus release slow over time. Have you done any research on the effect of these additives on the environment? For example, if we consider aluminum could be used to bind phosphorus, could be harmful to the environment, especially in acid soils. There is plenty of aluminum, and aluminum toxicity is one of the big issues in acid soils. And also, a scientific point of view, when you compare Rhizosorb with MIP or DAP, it's not logic scientific point of view because MIP contains nitrogen as well. In your trials, have you recompensated the amount of ammonium that has been supplied by MIP?
We
to
do.
be able to compare.
Yeah, we do adjust the nitrogen to account for that. On the active ingredient side, yes, it's a proprietary metal oxide. We have done studies and work on the aluminum side and showed that there isn't a concern at low pH or high pH, and we have shown it actually does work in this fashion at those pH levels. Thank you.